So the next question then is, this is on a table. What happens to this picture if I start spinning this in the air? So I don't know if you've ever had them, the little paddle balls that you can get with the strings that are, or they're kind of like rubber band things, and you can spin whatever you have, or some noise makers. So what you have is this vertical motion, this up and down. Oh, I hope I'm not making you dizzy by doing that. This up and down motion. So we're going to take this and flip it. And this time I'm going to go up like this. Make it clear. This is my hand holding it. I didn't do a stick hand body. Okay, there we go. There's two hands there, whatever. This is because I don't know how to draw. Okay, so I'm holding it and I'm spinning it. So it's going to be spinning like this away in the air. So at the top, let's see, what do I have? I have the force of tension. I need a different color. Ooh, force of tension down along that line, that away. But it's in the air. So I also have, ooh, force of gravity down that away. So at the top, when I do the summation of forces, whoops, I lost the page. When I do my summation of forces, let me move it down here. Sum of forces, center seeking. And remind myself, A points towards the center. So my net forces are towards the center. If I make this positive, down and to the right, why not? Then I get the force of gravity plus the force of tension equals mv squared over r. Okay, so let's think about this in terms of the force of tension, because I want to compare it to what's happening at the bottom. So if I keep it going at the same rate, then force of tension equals mv squared over r minus the mass of the ball times gravity, just moving the gravity over to the other side. Now let's take it, if I get it down at the bottom, and I need to make my legs longer, there we go, so it's not hitting the ground. Now it's at the bottom. So what do you think is happening at the bottom? Have I increased the tension or have I decreased the tension? Let's take a look. So what do I got? What do I got? I got, let's see, force of gravity coming straight down, and then the force of tension straight up. And then once again, my acceleration is pointing towards the center of the circle, so I'm going to define that as positive. So my force of tension and my acceleration are then going to be positive, but my gravity will not. And now I need to account for the fact that gravity is trying to break me from this circle. So I have, here's my force center. What do I got? I got force tension minus the force of gravity equals mv squared over r. Or I can rewrite this that the force of tension equals mg plus mv squared over r. So my tension is actually greater here, which kind of makes sense, right? Because at the top, tension and gravity are both going in the same direction. So gravity isn't fighting against me. It's trying to help kind of keep me going in that circle. Down here, gravity is fighting against me. So if it's fighting against me, then it's increasing the tension, because the tension is the thing trying to make the ball stay going in the circle. And hopefully my drawing doesn't give you nightmares.